Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk. We just broadcast just this morning before we got online to record today. Chris Jackson was doing a webinar, and it was on confidence. He's never a fan of short titles for his webinars. It's confidence it's all about you. It's not reliability. And he made the point is that, the reliability of, say, a wireless router, he's using a drawing of a wireless router. The wireless router you got in your home, it's going to fail when it's going to fail. It doesn't care how confident you are one day to the next or how anybody's decision or whatever it doesn't care. And when we were first chatting about it, he says, a brick has a certain reliability. And that's why we don't use them here in California, because some stresses cause it to fail. So
you don't use what in California?
Bricks.
Right.
Like,
I mean, actually, the
building material,
building block,
building block, physical.
They're brittle.
Bricks.
They
don't flex very much. They crumble when we have an earthquake, and a lot of chimneys fell down, and a lot of buildings fell down. So Philadelphia's got a lot of brick buildings. San Francisco, not so much. And part of that is because we know that material doesn't behave well in this environment.
Right.
And you've seen it with designs that people will say, we're going to use titanium here instead of polymers. Well, why are you doing that? Well, the internal temperature of this thing goes to 600 C, and we don't want to spend that much money on polymer that will soften. So we'll use titanium and, stuff like that. It's
it's just like that down oil well, down a measurement while drilling equipment that's going to go to 180 degrees centigrade.
Celsius, in sulfuric acid bath. What an environment.
Salt spray in the ocean, things like that. We build for those environments. But there's a lot of products that we don't know where they're actually going to be used, or they're going to be used everywhere, like cell phones, they're not going to be built uniquely for an area. So, confidence. Yeah, go ahead.
Well, the idea is that
not statistical confidence. We're not talking about that because that's something
you don't like to talk about.
No, I don't. When somebody says it's going to be 30% chance of rain, do you take an umbrella? I mean, these are all confidence, this is all probabilities. And that's just,
it does have a role. Let's say you're designing a brand new technology, brand new widget. You have no field history. The design team just invented it, and now we're trying to make a product out of it. I know what you do. You'd say, well, how does it fail? And we go to the lab and see how we can make it fail. And we explore it in different expected use stresses and then push it to see how much margin you have.
We understand the physics of it and the chemistry in it, and like these new quantum computing chips. I don't know what's in them.
Qubits.
Yeah. So, this may be a new physical process, a new structure in the semiconductor world. I don't know, but the understanding is, of course, you have much better modeling tools to understand what the physics are behind that, and it's on an intrinsic level, not without any external stresses other than the inputs to the chip. So once you understand that, and you have an understanding of the models, and then you go test those models and see if you're going to have some kind of degradation mechanism in it. You kind of look for those. You have to do some, if it's a brand new product, which is kind of what you just described, is a pretty rare situation that something's been created and never been before, and we don't know. I think there's some new battery technologies that are coming along that may be kind of new, and those will be all the chemistry of that. What is it? I think in China they're using a different. It's not lithium ion. It's another lithium kind of mix.
That's more stable.
It's more stable. It's,
Doesn't.
maybe has more cycles to it, things like that. So, but you're talking about a modem in the house or something like that. And I always think, well, the chances of it's failing intrinsically because of it's worn out are very
Oh,
low,
we're going to
very
go to
low.
our computers are going to demand a higher Wi-Fi frequency, and then that modem will be,
Right,
as you talk
exactly,
about, it'll be
exactly.
obsolete before it
We
goes
talk
out.
about, right, the evolution of Wi-Fi.
Oh no, I got this super duper modem in the house, and it was moving it to a different location for, and it's like, oh, I'm going to get the vacuum out because it's just full of cat hair and dust and
Right.
stuff. So I
Sure.
said, that might not make one whit of difference, but
Probably not.
I'm not. I did do it. I worked with a study. It was through CALS years and years and
Yeah.
years ago, and it was about
Yeah.
the design of heat spreaders, the fins you would stick on some hot chips way
Right.
back
Heat
when.
sinks.
Heat
Right.
sinks.
Heat
That's what I'm
sinks.
thinking of. And it was one of the issues that we saw was in homes, it would be pet dander and fur and
Right.
carpet lint.
Right.
People
Which acts as
walking
an
greatly,
insulator.
and it
A
would
thermal
coat.
insulator.
Yeah,
Right.
it would coat the the fins, and then they weren't near as effective.
Right.
And then it
Right.
would the chip would trip to a slower speed or turn off because
Right. Throttle down.
it
Right.
throttled
That's
down,
what
and then
chips
it's
do.
like, so the study it was perfect for a grad student. Like, create like 15 different styles of chips, do a bunch of different things, and then in a hot, humid environment with a lot of pet dander, which ones stick, insulate themselves too fast or not. And they're like, you want us to do what? This is, yeah. Here's some money, go work on it. And there were certain designs and airflows through the fins that clean them if you got enough of the right airflow and right turbidity to it or turbulence to it. It was really bizarre, and they did all kinds of formulas and all kinds of weird stuff. And then we had to go find somebody who would actually make them for us, but that was a different problem. But the gist of what
Chris was
talking about, was a good part of confidence is, well, how good is your data? I mean, just looking at it is, somebody comes to you and says, well, here's an exponential distribution, and it's a clear wear out mechanism.
Okay.
Like, no, they do not fail that way. Just because that's your favorite distribution doesn't mean it's useful for us to make a decision based on. And then the other part is taking, looking at confidence as, well, how well do you know the mechanism? How much margin is there? He said he was working on one that was a company that had was a transformer of some sort, and they had a sample of one from 3 different vendors, right? And so they wanted to do which one would last the longest. So they created a test that would, quickly accelerate based on, and they had some really solid understanding of the mechanisms they were
what were the do you know?
He didn't go into it. He didn't go into that, but
okay.
But Chris, I trust him to really ask those questions about, why are you using this?
Right. What
do
you know? Is it?
He knows the stuff about Arrhenius, and I don't think it was Arrhenius, it was something else. But anyway, let's say it was corrosion, right?
Okay.
And the chemical consistency of it, and you know how thick the plate is, and so you can really model pretty accurately. But they only had 3 samples, one from each vendor, so they ran this test that would replicate bits and pieces of their meaningful parts of their use environment. And they said, well, which one will last the longest, is the way they phrased the question. And they had this test running.
Okay.
And all 3 ran for the equivalent, according to their test setup, for 60 years. And one of them failed. The other 2 hadn't failed yet. And Chris said, and they were like, how do we make a decision here? He says, you only care about 2 years. Pick whichever one you want. They're all got great margin for your application.
Right.
And he said, well, how confident in you? You only had 1 sample. And he says, it's not going to fail. It's very unlikely that it's going to fail in 2 years for this mechanism.
Right.
So
for a specific mechanism.
Yeah, it's much more likely that you're going to install it incorrectly or damage it in
Right,
shipping
right,
than
right.
this stuff. So let's not worry about that. Let's worry
Right.
about the infant mortality, which is much more likely to cause a problem within the first 2 years than this thing wearing out. Well, that's not reliability. That's quality. I don't care what you call it. If it's going to fail in the field, why don't we fix that? Because it's not installed correctly or something. And so they went on to do that part of it. But his point was is that confidence, even the statistical confidence, is got to be based on, well, what do you know and don't know? And I'm thinking of why I wanted to talk to you, Kirk, is that if you all go off and you have this new transformer and you do halt testing on it,
Mm-hmm.
and just to pick a stress, let's say they're worried about temperature,
No.
and you get it to run for 6 hours at 180 degrees Celsius when it's
Mm-hmm.
likely ever going to see 80 Celsius,
Mm-hmm.
right? And it still doesn't fail. Or the first thing that fails is the, winding coatings melt, right? So you're
Right.
at a technological limit to this thing.
Right.
How confident are you that it'll work in use conditions?
I'm pretty confident well, there's other factors in that. Okay. Mm-hmm. One of the big factors is the manufacturing process stability. And, if I had 3 different samples of different companies and they all came out testing the same as far as the results go.
Mm-hmm.
And then, of course, you look at the price, but you also look at the history of the company, their size, what percentage of your business is what percentage of their business is yours. If you're using half of their capacity, then you really have to worry about what happens if that factory has a problem. Yeah. So there's just other major factors that I wouldn't worry about. Very old technology like transformers, unless there was a new insulator material, or somebody said, "Oh, we can use a thinner, insulating on the windings, things like that," or there would be something that changed that makes me cautious about it. But I'm not going to go test every ceramic capacitor or things for life, because I'm pretty confident that knowing the physics of these devices and depending on their environment, if I was in a high thermal cycling environment, yeah, that might be more of a risk. But then I'd subject those 3 to the most extreme thermal cycling. I'd do everything to see if I can get any of them to fail, as far as within reason. And you talked about limits, melting windings, unless it's below,
your expected operating range.
Yeah, it's not really relevant, although there was creep and some things over time. But thermal contraction expansion will also cause that wear mechanism to happen. So I think you talk about confidence, and the confidence is you have an understanding of the physics and the history of that particular component throughout the industry and a lot of different other conditions. And you kind of, that's where experience and knowledge of what's happened in other situations that have had major failures of transformers, that it was probably manufacturing inconsistencies. And so the one design that they sent you, which may have been the best of their production,
or the one they had available.
Maybe they selected that one to send to you as a sample. And then, they really don't have that consistent throughout their volume of manufacturing. They got, not capable. So I'm more focused on, and especially intrinsic reliability of components versus when they're put into an assembly and connected to other devices, is where the real complexity of failures happens. And like transients going through the transformer that may actually, cause a spike in voltage that, actually breaks through the insulator or something like that.
Yeah, I've seen that with the dielectric dielectric capacitor. I want to say dielectric capacitor, electrolytic capacitors.
Right.
Yeah. They have a voltage limit. They have a thin coating, and you get a spike coming through. It punch right through it. Now you have a resistor, not a capacitor.
And I think I had
don't like that.
I had a client that did have this situation, but they don't know why, because they never really looked at the actual
They
in
took the
circuit.
capacitors out and said, why did this fail? And they're like, well, it got us voltage spike, and capacitors don't create voltage spikes just all
Right.
by themselves.
Exactly. Something external's coming in and overstressing this thing incredibly and breaking down the dielectric. So, unless but there was nothing wrong with the capacitor itself. It was manufactured nominally, made, would have worked fine in other circuits. But this is the problem. It takes really, that would take, for this company to do that, would take a lot of effort that they didn't have. They only had one technician that was doing all the failure analysis, and he just, would cursorily do a cursory.
Yeah, there's a hole in the
Look.
capacitor. It must be the
Yeah,
capacitor's
exactly.
fault.
Yeah, right. Exactly. He says, "Yeah, how did you know it blow?" That was the thing. Yeah, well, there was a hole in it.
Yeah. Well, and that takes some discipline from the management team and everybody else, is go and ask that basic question: is, well, why did that hole appear there? And you see that in asset management and plant maintenance and factories and stuff. Is like, get the line running. I don't care why it failed.
Right.
Well, if I understood why it failed, I could prevent it from happening. More likely prevent it from happening. And I've had that happen, is where somebody say, what's the chance that this production line will consistently create products for a full week? We need to estimate how many units we can make.
Right.
We want to go at 80% capacity for the full week. And they're like, how well do you know your equipment? How good is your maintenance program? How well are these installed?
Exactly.
All that kind of stuff.
That gives you confidence.
Yeah. And then I also look at their histories. How many weeks out of the year do you run a full week without any downtime? And they say, well, never. I says, well, then your probability of this coming week of doing that is pretty low. I wouldn't say impossible, but pretty low, unless you've changed something in your process.
Mm-hmm.
And so I think the gist of this, the confidence idea, is that in some situations, statistics does play a role. Like Chris used the example of, what's the probability? The question posed in Chris's example was, should we offer a 2-year warranty? I think it goes back to this modem. And so they had some field data and say 30 points, and they put a Weibull curve on it. I know it's your favorite, Kirk. And he said, well, that's a little bit of information. That's okay. And we can draw confidence bounds on it. And that's, it gives you limits. Whatever confidence you pick, it'll give you upper and lower things. And that really doesn't, you show that to a program manager who's trying to make a financial decision, is like, well, sort of like, where's the beef? How do I interpret this?
Right.
So he went through a process of saying, well, and he ended up with, what is the over the confidence range? What's the probability of failure at the 2-year point? And then knowing the cost of failures. If it goes on warranty, it costs you this much. And here's how much profit we make if it doesn't fail.
Right.
And laid it all out and said, you have a 40% chance of losing money, and you have a 60% chance of making money. But overall, on average, with the information we have today, you're going to expect, on average, if we do this a bunch of times, 32 cents profit per unit instead of $10, which you were hoping for. Mm-hmm. Now they can say, it's not a clear yes, no, but it gives you a whole lot more information of saying, I'm taking the confidence from the data we had, confidence interval from the data we had, and then converting it into, this is the probability of failure and the cost or benefit from it. So overall, you're not going to make much money. You'll still likely be profitable, but you have a 40% chance that, you won't. You'll lose money. And so
40%, that's less than half though. I mean,
but it's not a linear thing. It's not like you make $10 profit in every unit.
No, right.
Because it's a distribution. It's not just limits.
Yeah.
So he was kind of explaining confidence as, it has to be tied to a decision. What are you trying to do? And how do you need to understand it? And this is not just statistics. how well did your previous product perform? How well did your production line perform? How well, it's,
And what were the causes of unreliability in all of those?
well, I don't know, probably dropping. Somebody stepped on it or whatever,
Yeah,
threw it against the wall.
exactly. Yeah. And so what can we do to improve that? What can we do to prevent that? What can we do to make that better? What can we do? How much would it cost us to fix this or make this more robust?
Yeah,
And that's where all to me the effort should be. That's where all the focus should be is what does it cost us to change this mechanism so it is not a major issue, or it's not the 40%, it's only 5%
yeah,
chance.
yeah,
you know
yeah,
what would that cost us? Yeah, and that's you'd use the same kind of evaluation of cost versus
yeah,
benefit ratio.
yeah.
And so maybe that's where I'll say, yeah, statistics can show you something, but it's all
You
probability.
heard it here, folks. Kirk actually acknowledged statistics might possibly be useful somewhere.
You might do it, but these things like Weibull counting parts as they failed, as opposed to knowing why they failed and what is in there that's causing it to fail.
Mm-hmm, mm-hmm.
And that tells me more of this. Is it a wear out? Is it a early life defects? Is it, infant mortality? All these things that are
Or
all
is it
these
a mixed
phrases.
thing? Maybe there's 15 different things failing and it's, all over the
Exactly.
map. And
Exactly. And that's why I get this is just, you know, and I don't Sendo, I think you do put up a lot of articles and things that are, besides the prediction, but
mm-hmm.
uh the recent articles I checked, that are still bringing up Arrhenius as a major factor in the failure of anything is it's very, again, very extremely limited and very specified cases, but it's still used widely and generally for fit rates and for
Yeah, all kinds of bogus stuff. Yeah.
oh
No, we
yeah, and
try
it's
to
just,
try to
and
tamp
I'm
that
just
down
going,
where
and
we
we're trying to
can.
move that away from this, and that confidence intervals and things like that. I'm going, as we just talked about, the confidence interval to me is how much knowledge you have of the past, how much knowledge you have of the physics, how much knowledge you have of the manufacturing process and the consistencies that have brought failures, and how much you're willing to go, again, everybody look at what's failed in the past, look at what, and it's hard to get. It's all hard to get because it's sometimes, most times it's somebody making a major mistake, setting a machine wrong, instructing people how to use it wrong,
Oh,
something like that.
sometimes it's our own fault. We tell our vendors to cut costs, and then they're like, "Why
Yeah, well,
doesn't
that's
your
what they
product
do.
work anymore?"
Or your procurement department saying, "Yeah, I'm cutting costs. I found this 5 cent capacitor only a
Savings.
penny."
Yeah, no, great deal. And yeah, sorry it doesn't work. That's your fault. Yeah, there's too much of that too. No, but the idea is so in listening to this,
Yeah,
Kirk, you and I,
confidence,
yeah, confidence is
confidence
way
levels.
more than it's more than a 90% confidence bound on whatever scant data you have. It really is
Yeah,
you got to think it through. It's a tool to help you think through, are you going to make a good decision or not? But it's not the total input into it. So I knew you'd have a good input on this one, Kirk. So that's why I brought it up. But if you're,
okay,
listening to this, if you want to see Kurt or Chris's webinar on its confidence, it's about you. It's not about reliability. It's about you.
right.
It's not a measure of reliability. It's about you. And
No.
we should have, well, hopefully the recording will be up before this podcast comes out, but we'll have to make sure we point to it. But if you've got a question about confidence or confidence intervals, or how do you make a good decision, or how do you know if you're on the right track, those kinds of things, let us know. Head over to ascendoreliability.com/go/SOR. A couple of ways to get in touch with us. Kirk and I and the other hosts of the show are available through LinkedIn and our about pages. And good part of this one was kicked off because of some of the questions that came up in this webinar this morning. So, we take questions all kinds of different formats and ways, and they're always interesting to talk about. So,
Yeah. Well, I'm confident, Fred, that we're going to talk about some more things for a few more times, and it certainly um, going to be my battle against uh,
Blind statistics.
Statistics, yes.
Yeah.
Blind statistics that aren't backed by actual physical mechanisms. That's what I think.
Yeah, there you go.
Where I
I can
stick
agree with you on that, Kirk. No
So
problem.
anyway, we'll certainly talk again.
All right. Talk to you later, Kirk. Take care.
Okay, Fred.
Bye-bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.